Welcome, intrepid explorers of the ancient world, to a journey back in time. Imagine a predator. Not one of the lumbering giants, but something far more agile, more intelligent, and infinitely more terrifying. A hunter whose very name, when translated from the Greek, sends a shiver down the spine. Deinonychus. Terrible claw. And for good reason. This wasn't just another dinosaur. It was a revolution. For decades, the popular image of dinosaurs was that of sluggish, cold-blooded reptiles. Think of the lumbering Brontosaurus or the slow-moving Tyrannosaur, locked in ponderous, almost comedic battles. But then, in the mid-20th century, a discovery ripped apart these long-held assumptions and forever changed our understanding of these magnificent creatures. This discovery wasn't just a new fossil. It was a revelation that ignited a paradigm shift in paleontology, sparking what became known as the Dinosaur Renaissance. Why was this one dinosaur so pivotal? What made Deinonychus so special that it forced scientists to rethink everything they thought they knew? The answer lies in its unique anatomy, its potential hunting strategies, and the groundbreaking research it inspired. This documentary will delve deep into the world of Deinonychus, exploring not just the creature itself, but also the incredible story of its discovery and the profound impact it had on scientific understanding and popular culture. From its fearsome, sickle-shaped claw to its surprisingly bird-like bone structure, Deinonychus challenged paleontologists to see dinosaurs not as mere overgrown lizards, but as dynamic, active, and perhaps even warm-blooded animals. How did a single fossil ignite such a heated debate and revolutionize an entire field of science? Join us as we unravel the captivating history of the Deinonychus, the dinosaur that truly roared, changing the landscape of paleontology forever. Prepare to meet the true architects of terror from the Cretaceous period. Before we dive into the specifics of Deinonychus, let's set the stage. For much of the 19th and early 20th centuries, dinosaur paleontology was dominated by a specific school of thought. Following the initial discoveries of giants like Iguanodon and Megalosaurus, scientists largely envisioned dinosaurs as slow, lumbering, cold-blooded beasts, much like modern reptiles. They were often depicted with sprawling limbs, dragging tails, and limited intelligence, suitable only for a sluggish existence in a swampy, humid world. This perception was heavily influenced by the prevailing scientific understanding of the time and the limited fossil evidence available. Most of the early finds were of large, herbivorous sauropods or heavily armored dinosaurs, which naturally led to the assumption of a more sedentary lifestyle. The lack of complete skeletons or clear behavioral clues further cemented this view. For example, the famous Brontosaurus was often shown wading in water, a hypothesis based on the idea that its immense weight would require water to support it. The field of paleontology itself was also evolving. Early fossil hunters were often adventurers and explorers, driven by curiosity and the thrill of discovery. While their contributions were invaluable, the scientific rigor and systematic approaches we see today were still developing. Data collection could be inconsistent, and interpretations were often highly speculative, based on limited comparative anatomy. The late 19th century saw the infamous bone wars between Edward Drinker Cope and Othniel Charles Marsh, a period of intense rivalry that led to a massive influx of dinosaur fossils, primarily from the American West. While this accelerated the pace of discovery, it also sometimes led to rushed conclusions and even outright fabrication in the race to name new species. Despite the competitive atmosphere, these discoveries laid the groundwork for future generations of paleontologists. However, the prevailing view of dinosaurs remained largely unchanged. They were magnificent relics of a bygone era, but ultimately, they were seen as evolutionary dead ends, doomed to extinction by their very nature. They were terrible lizards in the most literal sense, lacking the dynamism and complexity of modern warm-blooded animals. This traditional view was deeply ingrained in both scientific literature and popular imagination, shaping everything from museum exhibits to early cinema. The stage was set for a dramatic reevaluation, a paradigm shift that would challenge these fundamental assumptions and rewrite the story of dinosaurs. And the catalyst for this monumental change would be the discovery of a creature that defied all previous expectations. The year was 1964. In the dusty badlands of south-central Montana, near Bridger, a team led by Yale paleontologist John Ostrom made a discovery that would send shockwaves through the scientific community. They unearthed the remarkably complete remains of a medium-sized theropod dinosaur. This wasn't just another fossil. It was a Rosetta Stone of dinosaur evolution, a creature so astonishingly well-adapted to predatory life that it immediately challenged the prevailing view of dinosaurs as slow, cold-blooded brutes. What Ostrom found was revolutionary. The most striking feature was the oversized, retractable, sickle-shaped claw on the second toe of each foot. This isn't just a big claw, it's a weapon. This terrible claw was clearly designed for slashing and piercing, suggesting an active, aggressive predator. Its length, up to 13 centimeters, and its position on the foot meant it could be held aloft while running and then deployed with devastating force, much like a modern cat's claws. This feature alone hinted at a dynamic, agile hunter, a far cry from the sluggish reptiles of popular imagination. But the revelations didn't stop there. Ostrom's meticulous study of the Deinonychus skeleton revealed a host of other features that pointed to an active, agile lifestyle. The body was surprisingly lightweight, with hollow bones similar to those found in birds. Its long, stiff tail, reinforced by ossified tendons, served as a dynamic counterbalance, allowing for rapid turns and balance during pursuit or attack. Its powerful hind limbs were built for speed and leaping, suggesting a pursuit predator rather than an ambush hunter waiting in the shadows. The structure of its ankles and feet further reinforced this idea, indicating an animal capable of sustained, high-speed locomotion. Perhaps even more astonishing was the anatomy of its forelimbs. Unlike the small, almost vestigial arms of a T-Rex, Deinonychus possessed long, well-muscled forelimbs ending in three-fingered hands, each tipped with sharp claws. These arms were clearly capable of grasping and manipulating prey, suggesting a complex hunting strategy. The brain case, though relatively small compared to its overall body size, indicated a brain proportion similar to that of modern birds, suggesting a higher level of intelligence than previously attributed to dinosaurs. Its large eye sockets further suggested excellent vision, crucial for a predator. Based on these anatomical features, Ostrom proposed a radical new interpretation of dinosaur behavior. He argued that Deinonychus was a fast, intelligent, agile, and warm-blooded predator, capable of sophisticated hunting techniques, perhaps even hunting in packs. This was a direct challenge to the long-held dogma of dinosaurs as cold-blooded, reptilian creatures. Ostrom's protege, Robert Bakker, took these ideas even further. A passionate advocate for the Dinosaur Renaissance, Bakker argued vehemently that dinosaurs were not only warm-blooded but also highly active, intelligent animals. He used Deinonychus as his prime example, pointing to its athletic build and predatory adaptations as undeniable proof. Bakker's fiery rhetoric and compelling arguments, often presented with striking illustrations, galvanized the scientific community and captivated the public imagination. His famous phrase, "Dinosaurs were just big birds," though provocative, highlighted the profound evolutionary link. The idea of pack hunting in Deinonychus gained significant traction due to associated fossil finds. Multiple Deinonychus teeth have been found alongside the remains of the much larger herbivore, Tyrannosaurus. This was particularly intriguing because Tyrannosaurus was significantly larger than Deinonychus, typically weighing over a ton, while Deinonychus was around 70 to 100 kilograms. This size disparity strongly suggested that a single Deinonychus would struggle to bring down such a large prey item alone, implying cooperative hunting. While direct fossil evidence of pack hunting is rare and difficult to prove definitively, the anatomical features of Deinonychus, its speed, agility, weaponry, and potential intelligence, make the pack hunting hypothesis highly plausible. Imagine a coordinated group of these terrible claws strategically attacking a much larger opponent, using their intelligence and agility to overcome sheer size. This was a game changer. The impact of the Deinonychus discovery and the Dinosaur Renaissance extended far beyond academic circles. It fundamentally altered the way dinosaurs were depicted in popular culture. No longer were they slow-moving monsters. They became dynamic, fearsome creatures, inspiring new generations of filmmakers, artists, and writers. This shift culminated most famously in Michael Crichton's novel Jurassic Park and Steven Spielberg's subsequent film adaptation. The velociraptors in Jurassic Park, though significantly larger and more intelligent than their real-life counterparts, and largely based on Deinonychus, captured the public's imagination and cemented the image of intelligent, pack-hunting dromaeosaurids. This film, more than any scientific paper, brought the Dinosaur Renaissance to the masses, showing a terrifyingly plausible vision of active, bird-like dinosaurs. However, it's crucial to distinguish between scientific understanding and cinematic dramatization. The raptors of Jurassic Park are largely an amalgamation, with their size more akin to Deinonychus, and their intelligence perhaps exaggerated for dramatic effect. Real Velociraptor from Mongolia was much smaller, about the size of a turkey, though still a formidable predator. But the underlying scientific premise, the idea of intelligent, agile, bird-like dinosaurs, was a direct result of the Deinonychus revolution. The discovery of Deinonychus not only changed our perception of dinosaurs, but also contributed significantly to the growing understanding of the evolutionary link between dinosaurs and birds. The numerous bird-like features observed in Deinonychus and other dromaeosaurids, such as hollow bones, furcula, wishbone, and even a strong inference of feathers, though direct fossil evidence for feathers on Deinonychus itself is still debated, extensive evidence from closely related species like Velociraptor and Microraptor makes it highly probable, provided compelling evidence for the avian origins. This was a monumental shift, transforming dinosaurs from ancient reptiles into direct ancestors of the birds we see today. The roaring T-Rex in our imaginations slowly transformed into a giant, feathered ancestor to a hummingbird, all thanks in large part to the compelling evidence presented by Deinonychus. Today, the legacy of Deinonychus continues to shape our understanding of dinosaurs. The Dinosaur Renaissance sparked by Ostrom and Bakker has blossomed into a vibrant field of research, utilizing cutting-edge technologies and interdisciplinary approaches. Paleontologists now employ advanced imaging techniques, biomechanical analyses, and even molecular studies, where possible with exceptionally preserved fossils, to reconstruct the lives of these ancient creatures with unprecedented detail. The debate surrounding dinosaur physiology, once a heated point of contention, has largely shifted toward the consensus that many, if not most, dinosaurs were indeed warm-blooded or at least mesothermic, a metabolic rate between warm-blooded and cold-blooded animals. The evidence from bone growth patterns, predator-prey ratios, and anatomical features like those found in Deinonychus strongly supports this revised view. The idea of active, dynamic dinosaurs is now firmly established in scientific literature and public consciousness. One of the most significant ongoing discussions related to Deinonychus and its relatives is the presence of feathers. While no direct feather impressions have been found specifically with Deinonychus fossils, its close relatives, such as Velociraptor from Mongolia and numerous other dromaeosaurids and non-avian dinosaurs from China, have yielded spectacular fossil evidence of extensive feather coverings. This has led to a strong scientific consensus that Deinonychus very likely also possessed feathers, possibly for insulation, display, or even as aids in hunting or gliding. Imagine a Deinonychus not as a scaly reptile, but as a formidable, feathered predator, a truly bird-like dinosaur. This ongoing discovery and interpretation of feather evidence is one of the most exciting frontiers in dinosaur paleontology. Modern research also focuses on the biomechanics of Deinonychus. Scientists use computer simulations to analyze how its limbs moved, how its jaw muscles functioned, and how its sickle claw was employed. These studies provide deeper insights into its predatory capabilities, confirming its speed, agility, and the devastating power of its primary weapon. For instance, detailed analyses of the claw's articulation suggest it was used not just for slashing, but potentially for pinning prey, similar to how modern birds of prey use their talons. The impact of Deinonychus is also evident in museums and educational programs worldwide. No longer are dinosaurs presented as lumbering giants. Instead, museum exhibits now feature active, dynamic poses, often incorporating realistic feather reconstructions, reflecting the latest scientific understanding. Deinonychus, with its iconic claw, often takes center stage as an example of a truly active and intelligent dinosaur. However, challenges remain. The fossil record is inherently incomplete, and much about Deinonychus's behavior, social structure, and precise hunting strategies still relies on inference and comparative anatomy. The exact nature of its pack hunting behavior, for instance, remains a subject of ongoing debate and research, with new evidence continually being sought and interpreted. Furthermore, while we have a good understanding of its physical form, understanding its exact vocalizations or precise cognitive abilities remains elusive, pushing the boundaries of what can be inferred from bones alone. The fossilization process itself is a rare event, so finding complete individuals or direct evidence of behavior is incredibly difficult. This means that while we've come a long way, there's always more to learn and more mysteries to uncover about the terrible claw. What does the future hold for our understanding of Deinonychus and its kin? The pace of paleontological discovery is accelerating, driven by new technologies and a global network of dedicated researchers. We can expect even more incredible insights in the years to come. One major area of future focus will be the continued search for more complete Deinonychus fossils, particularly those that might preserve soft tissues or direct evidence of feathers. Discoveries like the feathered dinosaurs from China have revolutionized our understanding, and finding similar preservation for Deinonychus would provide definitive answers regarding its integument. Imagine a fossilized Deinonychus with clear feather imprints, revealing its exact plumage coloration and pattern, a truly breathtaking prospect. Technological advancements will also play a crucial role. Artificial intelligence and machine learning are increasingly being used to analyze vast data sets of fossil information, identify patterns, and even predict the likely characteristics of extinct animals. These tools could help us refine our biomechanical models of Deinonychus's locomotion and hunting techniques, providing a more precise understanding of its athletic capabilities. We might even see highly accurate robotic reconstructions, built based on these detailed analyses, that could demonstrate its movements in real time. Furthermore, advances in paleogenetics and paleoproteomics, while challenging for such ancient fossils, might one day allow for the extraction and analysis of preserved proteins or even fragments of DNA. While a Jurassic Park scenario of resurrecting dinosaurs remains firmly in the realm of science fiction, such discoveries could provide unprecedented insights into the physiology and evolutionary relationships of Deinonychus. Imagine unlocking genetic secrets that tell us about its metabolic rate or even its sensory capabilities. The study of paleoecology will also continue to deepen our understanding of Deinonychus's environment. More detailed analyses of the plant life, climate patterns, and other animal species present in the early Cretaceous period will paint a richer picture of the ecosystem in which Deinonychus thrived. This will help us better understand its position in the food web, its interactions with prey and competitors, and the environmental pressures it faced. For instance, understanding the specific vegetation of its habitat could give clues about where it might ambush prey or find shelter. Finally, the ongoing exploration of new fossil sites around the world holds immense promise. New discoveries of dromaeosaurids or related theropods could shed further light on the diversity and evolution of this fascinating group, providing comparative data that strengthens or refines our understanding of Deinonychus. Every new bone, every new fossil footprint adds another piece to the puzzle, gradually revealing the full story of this remarkable predator. The future of Deinonychus research is bright, promising a continued unveiling of its secrets. As technology advances and new fossil finds come to light, we will undoubtedly gain an even more complete and vivid picture of this terrible claw and its enduring legacy in the annals of prehistoric life. The journey of discovery is far from over. From its initial discovery in the Badlands of Montana to its starring role in the Dinosaur Renaissance and beyond, Deinonychus has left an indelible mark on both science and popular culture. It was more than just a fossil. It was a catalyst, a living embodiment of scientific revolution that shattered long-held misconceptions about dinosaurs. We've seen how its distinctive features, the fearsome sickle claw, the agile, bird-like skeleton, and the implied intelligence, forced paleontologists to rethink everything they knew. Deinonychus wasn't a sluggish lizard. It was a dynamic, active, and potentially warm-blooded predator, a creature that redefined what it meant to be a dinosaur. The legacy of Deinonychus lives on in every feathered dinosaur reconstruction, every dynamic museum exhibit, and every new scientific paper exploring the complex lives of these ancient wonders. It remains a cornerstone in the argument for the bird-dinosaur link, a powerful reminder that the birds soaring above us today are the direct descendants of these magnificent and sometimes terrifying creatures. So, the next time you see a bird or ponder the ancient world, remember the terrible claw, Deinonychus. It's a testament to the power of scientific discovery to challenge assumptions and ignite new understandings, reminding us that the story of life on Earth is always more complex, more surprising, and infinitely more fascinating than we could ever imagine. The roar of Deinonychus echoes through time, a reminder of a remarkable creature that forever changed our view of the prehistoric world.